Hi guys, the last type of statistical test that we learn in AP statistics is the chi-squared test. So the data that we're going to use come from a few weeks ago. We did a test where we considered whether the proportion of one color of regular Skittles was different from 20%. There are 5 different colors of Skittle in the bag. So what we're going to ask today is a slightly different question. Do these sample data that we had a few weeks ago provide evidence that the proportion of each, not just one of the colors, but that each of the 5 Skittle colors is different from 20% in the population? So do you or don't you get 20% of each color of Skittle in the entire population of Skittles? So one of the things we need to do is write down our actual counts for the different colors that we had a few weeks ago. So if I wrote it down correctly, we had 75 red Skittles, 69 orange, 78 green Skittles, 68 yellow, 97 purple Skittles, and the total number of Skittles was 387. So there's our sample data. So the question then becomes, what should our null and alternative hypotheses be? So like any other statistical test, there are 4 parts. We start with our hypotheses. So the null hypothesis, still written HO, is that the proportion of each Skittle color in the population is 0.2 or 20%. If nothing special is going on, they're all 20%. So we're looking for evidence that they're not all 20%. Pretty simple. That's the alternative hypothesis. So the proportion of each Skittle color in the population isn't 0.2, isn't 20%. Well, very good. There's our null and our alternative hypothesis. So remember, in a statistical test, we are ultimately going to create a p-value, and our goal is to decide, are our sample data, are our actual counts, are these counts unusual? Are they special? If the null hypothesis is true. So if the null hypothesis is true, we need to figure out what would we expect to get. This is what we actually got in our bag of Skittles. What would we expect to get? If the null hypothesis is true, the expected counts well, what would those be? It's not too hard. There were 387 Skittles. 20% of 387, that is 77.4. So we would expect to get 77.4 of each color. So up here, these are the actual counts: 75, 69, 78, 68, and 97. The expected counts are all the same. They're all 77.4. So if we get 20% of each color, this is what to expect. Now, there is natural variability. There is natural variability, so our samples won't always nail what we are expecting to get. There is natural variability. The question then becomes, are these values that we saw in our sample, are they different enough from what we expect that we believe we have evidence to reject the null hypothesis in favor of the alternative? So either way, we have a total of 387. So, second step, the conditions. We've written the null and the alternative hypotheses. Here are the conditions. So like other situations, I need to believe that I have a random sample. So we have to act as if this bag of 387 Skittles is a random sample. So we're going to act as if our bag of 387 Skittles is a random sample. I suppose at some level we have no reason to think that it's not a random sample. So the next thing to look at then is the counts. So understand, when I say the counts, what we're really looking at are the expected counts. So is our sample size big enough so that all of the expected counts are 5 or more? So really, we're interested in comparing the expected counts to a boundary. What we typically do is compare to 5. So all expected counts, not the actual ones, the expected ones, are greater than or equal to 5. That's the condition, and certainly in our situation, 77.4, that's certainly greater than or equal to 5, so that is met. What this condition really says is based on the null hypothesis. So in this case, the null hypothesis is a simple one. We expect 20% of each color. Of course, in different contexts, you can expect if you have 5 counts, you might get 25% of one color, 10% of another color. I mean, you can set up a null hypothesis however you like. This is the simplest situation where we get 20% of each, so all of the expected counts are the same. So I suppose you could have a situation where one of your proportions might be really small. So what that means is for the expected counts, your sample size has to be big enough so that your expected counts all exceed at least 5. So if one of your hypothesized proportions is really small, you need to make sure that you have a large enough sample so that even for that really small proportion, you have an expected count of at least 5 in order for us to have a chance of getting some of those in the actual sample so that we have a basis for comparison. So first step, hypotheses. Second step, the conditions. There's the randomness condition, and then there's the condition regarding the expected counts. So the third and fourth steps are to name the test, develop the statistic, the degrees of freedom, and the p-value. And then the last thing, like every other test we do, we will draw a conclusion. So we will do those last 2 steps in the next video.